Hi, this is Dr. Graves from the California State University Geography Department. This is a video tutorial that is designed to help students learn how to use an online website called Statskingdom.com to do inferential testing using something called a t-test to compare quantities of data, the averages, between different groups. So let's go ahead and get started. The first thing that I'll have you do is download some data. Here's various options if you're in my class. Otherwise, look for the link in the video. And I'm going to open this data in Microsoft Excel to start with. I'll click Enable Editing, and then I will give it a slightly different name. And so what we have is arrest data for the city of Los Angeles over a period of some years. This file has been reduced from the original videos associated with this. So the first thing we're going to do, in order to just give you a little extra practice with all of this, is to reduce the data into a more manageable format so we can see what's going on. This may not please the statisticians in the group, but it will serve our purposes. So we're going to click Insert and Pivot Table and click OK. A new sheet will appear, and what we want to do is to construct a table of arrests for some violation by region of the city or police precinct and by major ethnic groups. So what we want to do is grab age over here in the pivot table field and grab it. That's click and then drag it into the value fields. So that we don't want. We want the to change the values field settings. So click on the down arrow next to sum of age and change that to average. Click OK. That's fine. And then let's grab area name and put it over here in rows. And so these are the various precincts within Los Angeles. And then let's grab a descent code here and put it in columns. And there are a lot of various options that the police department has for putting in descent code. This seems a bit too much. And then we'll do one other thing, which is so grab charge group description and put it in the filters box. So now what we want to do is to cut down on the data, to narrow it down a little bit using filters. So click on the charged group description to the right of where it says all. There's a down arrow, and click select multiple items and then deselect everything by clicking all. And we can just pick something that is common, like robbery. So robbery, and click OK. So then that narrows it down somewhat. And then we want to filter our descent codes down to just those that are large enough to have good representative samples. So unselect all, select B for blacks, H for Hispanics, O for other, and W for white. And that should give us what we basically need to do this. But as we see that there's a blank here in the Hollenbeck division for other. So I suspect that there aren't enough robberies to give us a robust sample of arrestees. So let's add aggravated assault to that and click OK. And now we have a sort of robust affair. Let's just check and put report ID down here next to values, and then change that from sum of to value field settings. Click on that and change it to account. And so we see that we have plenty of counts here, so there's enough people in every one of these categories that we have a good solid representative sample, or at least good enough for the purposes of this study. So the first test we want to do is to do a one sample T or Z test. And in this case, what we're checking is to see if any of our ethnic groups, blacks, Hispanics, others, or whites, are significantly different in terms of their average age than the overall group. So we're comparing these individual samples to the larger population. So here is the average age for everybody down here at 33.961. So what we want to do is pull away from this and bring up statisticsKingdom.com, and if you want to, you can just Google that. And the first one is this one sample t-test. So we're checking the mean of all against the various samples. So in this case, we had a mean of 33,906, so I can copy that cell value and put it here in the expected mean. That's what we're expecting. We will leave it set at significant level because we want to be sure, and we'll leave it at 2 tails. But if you think that it's bigger or smaller, you want to check to see if it's significantly bigger or smaller than the other group, then you can change it to either a right-tailed or a left-tailed test. But we'll just do the two-tailed test, which asks, is the group that we're going to compare to the overall mean significantly different? And we're going to enter our data raw. Much easier to enter the raw data from Excel for us. And so we go back over to Excel, copy the B plus the values for each of the groups, and come back here and simply Control V to paste in. Once that's there, click Calculate, and it gives us a readout. You will grab a screen grab of that, but it also helps us understand in plain language what's going on. The p-value is 0.06, and that tells us that the difference is not significant. It's very close to being significantly different, but it is not significant. So the p-value means the chance of type 1 error is too high, so we have a 6.43% chance of being wrong, and that's if we said that the two samples were different, and so we have to accept the null at that point. So that's the one sample difference. So let's jump back to these mean tests and do a two sample t-test, and we'll use the one here. We'll go with the two sample t-test, the Welch's test, and in this case we're going to also use the two-tailed test to see if these two samples are different. We're going to select paste Excel data, come back over here to our two samples, and we're going to ask, are the people arrested who are black significantly different in terms of their average age than those who are arrested who are Hispanic. And we can see that the average age for blacks is 35.8 and for Hispanics 31.3. So we can see that they're definitely different. But the question is this a significant difference? So click copy and then paste. Click calculate sample. And we see that they're not exactly the same in terms of their distribution. And so there's some normality issues with this, but we're going to go ahead and calculate the test anyway. So in this test, it says the p-value is very small, and so we are rejecting the null hypothesis. And so the average of black population is not equal to Hispanic population. And we could see that there was a difference. It is a statistically significant difference. And that p-value is so small that it's in our chance of being wrong when we say that the two groups are different in age is exceedingly small. So there are some questions about the data itself, and of course we're using convenience data, but that is essentially that two sample test. The third test that we're going to use requires us to go back over here to Excel, and what we want to do is grab arrest date and put that down there. And you can grab quarters and arrest date and get rid of it. And so what we want to do is to compare time 1, say here, to time 2, say in 2019, and we want to see, is there a significant decrease in the age of arrestees from time 1 to time 2. Maybe we're trying to get juvenile delinquents off the street and we want those ages to perhaps increase as a sign that there are fewer juvenile arrests. So we can come back over here to Statskingdom.com, go back up to these means test or to home. And so this is called a paired t-test, and it basically is a before and after. Okay, and we can leave the settings at the default, and let's grab 2015's data and copy it, and we can paste it here into the before. Maybe we change that to 2015, and then our after in 2019. Control copy and paste that in here and call that 2019 and calculate the test. So what does it say? P-value, that there is very small. The t is 0.45. So we scroll down here and we reject the null. 2019 population average is considered to be not equal to. And so there was a difference between the two groups in terms of 34.4 and 33.6. It doesn't seem like much, but that is a significant increase in the average age of the two groups. And so this is how we would do that to prove that our program had a significant effect on the arrest age. That concludes this quick video tutorial on t-tests.